So welcome to lesson 6.4, which is all about logarithms and logarithmic functions. Now you're probably saying, what in the world's a logarithmic function? Well, really what it is it's an inverse of an exponential function, the stuff that we were talking about in the previous sections. If you would take a look at the graph of the two functions here, and this one is, the blue is y equals 2 to the x, and the red is technically, we're going to say it's x equals 2 to the y. You'll see the reflections of each other over the line y equals x. Think about how we found inverse functions. If we had a function, we took f of x out, put y in, and then what was the next thing that we did? We flip-flopped x and y. And then we continued solving to get it in correct function form. But right now I'm just leaving it this way. Y equals 2 to the x and x equals 2 to the y. So you can see how the bases stayed the same, but x and y flipped spots. And you see that in the ordered pairs. X's and y's just flip spots all the way through. Now, written out, really what it is you have a base to an exponent equals a number. That's exponential form. This is what we looked at last week. But now, logarithmic functions, we have a log to a base b, whatever that number is. We say log of base, whatever number b, of x, of some number, is y, some exponent. So really what we're saying is, look something like this. Think about this one. This is one you should know. 2 to the third power, it equals 8, right? 2 times 2 times 2, it's 8. Now, if we wrote this in not exponential form, but logarithmic form, we would say the base 2 log of 8 is 3. So if we took 8 and we took it to a power of 2, or not, if we took 8 and had it as 2 to a certain power to get 8, that exponent, that power, would have to be 3, okay? We're going to spend most of this lesson going between exponential and logarithmic form, this direction, and then logarithmic form back to exponential form, and then a little bit of evaluating logarithmic functions, so the stuff without the equals here, and we'll show how we actually go about solving that. Okay, so now we're going to take a look at some logarithmic functions and turn them into exponential form. So we're going to keep, everything's going to be the same, it's just they're going to be in a different format. So we want to get it into b to the y equals x. So remember before we keep our base. So we're going to have 3. There's our exponent, the second equals 9. And we would agree, 3 squared equals 9, correct? Correct. Now, some people look at this, they go log, so that's the first number, so I'm going to deal with that. That's going to be my base. What's my base? This is power. 2 is over here, and then what's left, that's got to equal what's left. Or, you'll see this a lot in our particular book, they'll start with the 9, and they'll say 9 is equal to what base to what power. Either answer is fine. It's really a matter of how you look and interpret it. I'll probably actually do more like this just so that matches if you go look up anything in the book. So we've got the base 10 log of 1/100th to the negative second. You think, uh-oh, we got a fraction and a negative power. Oh dear. But remember, fractions really are just negative powers. So we've got 1/100th. That has to equal our base, and here's our exponent. So as you're looking at any of these, you're seeing here's my base, here's my exponent, here's the number that I need. Number equals base to the exponent. That's pretty straightforward, right? All right, well now what about this one? The base 4 log of 1/16 equals negative 2. Take 1/16. It's got to equal our base, to our power, -2. And that's all you're doing when you're putting stuff into exponential form. You don't have to do any further simplification. Okay? Okay, now we're continuing and we've changed our form here. Now we've got exponential form and we're trying to go to logarithmic form. So that means we're going to be looking to write things as log of the base, whatever it is, of x equals y. So our base is the number which equals the exponent. All right, so we don't have to do any calculations again. We just have to rewrite the problem. So we're going to write down log. What's our base? That's 5. What's the number? 125. And the exponent equals 3. So here we go. There's our base. There's our exponent. And here's our number. All right, so let's look at this one. Oh, a 1/3 power. Oh dear, whatever are we going to do? I think we'll be okay. All right, so we write down our base, log of 27. The base 27 log of 3 is 1/3, because really a 1/3 power means we're taking the cube root of something. Okay, and what's the cube root of 27? It's 3. So just a quick little check you can do in your head just to make sure you're solving things correctly. And then over here we got 3 to the 4th equals 81. So that's going to be the base 3 log of 81 equals 4. So hopefully you're seeing how those are working. Okay, so now we are going to evaluate the logarithmic expression. So you notice it doesn't our log expression here doesn't equal anything. So that's going to become a focal point of what we're doing to solve. So there's our problem. The base 3 log of 243. We've got to solve. Or evaluate it. So the first thing we're going to do is we're actually going to set it equal to y. Now we're going to rewrite it as an exponential function. So we're going to say 3 to the y equals 243. Or, since we've been doing it the other way, I'm going to erase that. I'm going to write it the other way, actually. 243 equals 3 to the y. So now we're going to rewrite in exponential form. And then solve. Solve like you have been in previous lessons when you have an exponential equation. So that means we've got to get matching bases. 3 to what power gives me 243? Think. 3 to the 5th. So now we got matching bases, they're gone. Y equals 5. So now solve for y. We're going to do that every time, no matter what our bases are. You'll see a couple other examples here of how the bases could look a little different and how we might have to do a little bit of solving as we go. All right, we got the base 10 log of 1,000. So first thing we do, set it equal to y. Now, if you're doing this just on paper, you can just go equals y. I'm keeping this up here just to keep the integrity of the original problem. Not 10 equals y. There we go. Base 10 log of 1,000 equals y. Rewrite it in exponential form. 1,000 equals 10 to the y, base to the exponent. I have to have matching bases. 10 to what power is 1,000? Hopefully you're saying 10 to the 3rd equals 10y. So therefore y equals 3. Now, let's maybe change it up and make them just a little bit more challenging here. So I'm going to erase these. And going to look at my notes over here so I can see what I want to do. And I would like to do the log of the 121st base of 11. You're going, holy cow, a 121st base? Wow, that's huge. Don't freak out. So we're going to do the same process. Set it equal to y. Write it in exponential form. 11 equals 121 to the y. to get matching bases. I can break 11 down. 11 is 121. That's actually 11 squared. So I've got 11 technically to the first equals 11 to the 2y. 11 squared times y. Now, matching bases, 1 equals 2y. Solve for y, divide both sides by 2. Y equals a half. So here we had to do just a little bit of extra solving, but totally doable. It's not like we're doing major algebraic problems here. And we're getting back down to some simple one-step algebra. All right, one more that I'd like to look at. Okay. Log of the 1/6 base of 1 2/16 equals 3. Now that's a mouthful, right? We got fractions, but we're going to be okay. I promise. Set it equal to y. So log 1/6 base log of 1 to 2/16 equals. Okay, I just totally blew this problem. There, we didn't see that 3. You never saw it, okay? Equals y. Okay, write in exponential form. 1 2/16 is equal to 1/6 to the y. If it helps, the parentheses around it. All right, now we want to get matching bases. They should be whole number bases. So this side, let's think about here. That's 6 to the -1st times y. 2/16 is 6 to the 3rd, but it's a fraction, so it's 6 to the -3rd. I think you see where I'm going with this, especially after I accidentally had the answer written up there. So matching bases, -3 equals -y. Divide both sides by -1. Y equals 3. Good, match what I originally wrote up there. So hopefully you're seeing the process now for solving. One, how we go between logarithmic and exponential functions and exponential and logarithmic, as well as how to evaluate them. Coming up in the next part of the lesson, we'll look at the graphs a little bit and how they shift around. And I imagine you'll discover this looks really familiar, like we've seen graphs do that before. All right, have a good day.